All right, guys. So, if you did not get to this part in your class the other day, you can kind of skip through ahead into the video. Some classes, or maybe one class, didn't get to this part. This is in 4.5 for the tree diagrams. Question number 11 on page 2. This is talking about playing rock paper scissors against a friend. Who gets to ride shotgun? You'll play best 2 out of 3. You guys have all played rock paper scissors before. It says usually have a chance of winning about 60% of the time. 60% is 0.6. Just to remember that, or 0.60. You're going to create a tree diagram. I did this in the PowerPoint with most of the classes that we got to this far. Here's how you make your tree diagram. I'm just going to kind of roll through it. When you play rock paper scissors the first time, you got 2 options. You got to either winning or losing. Now, this is not an equal probability. It says you have a 60% chance of winning. So we're going to put 0.6 on the win, which is 60%. And that means you have a 40% chance of losing, which is 0.4. Now, whether you win or lose, it's best 2 out of 3. So you get to throw a second time. You get to shoot a second time. Even if you win, you get another probability of winning or losing. Or if you lose, you get to play again. Again, same probabilities of winning or losing. Now, at this point, you have a 60%, or I'm sorry, at this point you can either if you win, hey, the game's over. You've won the best 2 out of 3. Or if you lose, game's over still, but you lose, your friend wins. Now, if you lose, or you win, you still get one more chance to shoot. So we have to branch this out one more time. And then you can kind of see where you actually win or lose overall. If you win, lose, win, obviously you win. If you win, lose, you lose, and so forth. So there's 6 different outcomes here. 3 of those outcomes three of those outcomes, like here. Let me see if I can get this to work. You win, and 3 of those outcomes you actually lose. So those are the different possibilities here. So pause the video, get this question, get into number 11. I'm going to keep rolling through here so we can answer some of these questions. Going back to question number 12, where it says, what is the probability that you win in just 2 throws? Well, as you guys are doing this particular tree diagram, what I would do on number 11 is, hey, find the probability of every outcome. There's 6 different outcomes. And if you remember from the lesson, the way that you find the probability of a particular outcome is you multiply. So you're going to multiply. I don't know why my pen's not working here. On this screen, and I'm gonna pull this back up again. All the way through. What I would do on question number 11 is actually multiply each of these outcomes to figure out what this is. So in order to figure out how many times, what's the probability of winning and winning, we take 0.6 and we multiply by 0.6. Off to the side, I would just put 0.6 times 0.6. And this will give you the probability of winning just in the first 2 throws. If you multiply that out, you get 0.36, which is 36%, as we all know. Then continue going. Find the probability of winning, losing, and then winning. So you're going to multiply. I'm going to do this in a different color. You're going to multiply 0.6 times 0.4 times 0.6. You do that over here. And I believe if you multiply all 3 of those, again, you can show your work on here. 0.6 times 0.4 times 0.6 is 0.144. So I'll just put 0.144 here. Make sure you show your work. Continue doing that. To find what's the probability of losing right here. Well, 0.6 times 0.4 times 0.4 gives you this right here. And then so on. Down here, 0.4 times 0.4 will give you what the probability is right here. Pause the video. Give yourself some chance to do that. I'm going to clear the screen and keep going on. Going back to the assignment. question number 12 says, what's the probability that you win in just 2 throws? Don't forget that you want to put probability notation. You can just put P 2 throws. And going back to the screen here, well, we can see the probability of winning in just 2 throws this is it right here. So whatever you got right here a second ago, which is I think 0.36, that's the probability. There's the decimal, and then the percentage is 36%. Number 13 says, what's the probability that your friend wins? Your friend wins here, here, and here. Let me clear the screen. So your friend wins here, here, and here. Well, once you found those probabilities by multiplying, what are you going to do with all three of those together? You're going to add them. So add all three of those probabilities together, add them as decimals or add them as percentages, and you will get your answer. Number 14, what's the probability that you have to use a third throw to determine who gets to sit shotgun? Again, the same thing. You're going to do the same thing. Clear the screen. There's 4 ways that you have a third throw. All 4 of these ways. Once you find those probabilities by multiplying, again, you just add them together to get your answer. The last question is the one that's probably the most difficult. What is the probability that you win given that you already won the first throw? So this is question number 15. Make sure again that you're using notation. So you're going to look number 15. You're going to do something like probability that you win given that win the first one. Okay, so you can do first throw or just first. I'm going to make this easy on myself. So there's your notation for number 15. Now, the hard part here is that there's no we don't necessarily need to use the formula to figure out the answer to this problem. And a conditional statement for tree diagrams, hey, this has already happened. Your probability of winning, given that you win the first time, has increased because you already won the first one. So basically, if you've already won the first one, this is gone. And all we have left is whatever's on this side. So now I just need to figure out I need to ignore this and figure out my probability of winning here. And actually, take that back, because if you won the first one, then all that matters actually. Let me go back. All that matters is not this one. I can't. Let me clear screen. If you win the first time, none of this actually matters right here, because you've already won. So we just got to focus in on this top part. So since you've already won, this is gone now. What's your probability of winning now? Well, you can win right here, and you can win right here. So you can win the next one and you're ready. That's already 60% right there. 60% is how much you win right there. You could lose the next one and then win the last one. So 0.4 times 0.6. Figure out what 0.4 times 0.6 is. Figure out what percentage that is. And then just add these two together. And that would actually give you your answer to question number 15. Pause the video, do the math. I believe you guys can do 16 through 18 on your own. Go ahead and try that on your own. Number 19 through 25 is just like the first part that we talked about yesterday or the day before, depending on what class you're in. Count up the total possibilities over here first. So figure out how many total combinations of shoes and outfits, all these ending branches, and all that's going to be divided by that. So everything here is going to be divided by the total. Okay, everything's going to be divided by how many there possibly are, and just count up how many satisfy each one. The last one I'll kind of go through is the last section right here. Let me see if I can pull this up so I can notate it. I think I can do this that way. All right. I don't know why I can't get the tools to come over to this page here. So you're just going to have to listen, hopefully get some answers here. The very last section, I'll help you set up this tree diagram. It says a local university offers a review course for those who are planning to take the GRE exam. 30% of the people who took the exam had attended the university's GRE review course. The results of the test showed that 60% of those who attended the review passed the exam, while among those who did not attend the course, only 20% passed the exam. So fill in the blanks, and we're going to add percentages to the tree diagram. So these first two slots right here are basically the first slot is they took the course, so they took the review course, and then they did not take the review course. So this first section would be took review course, and then section one would be did not take the review course. It tells us in here that 30% of those people took the review course. So on this first branch should be 0.30 or 0.3 for 30%. Now, if 30% took the course, then 70% or zero point 0.7 or 0.70 did not take the course. So you're going to put 0.3 here and 0.7 here. And then after that, there's two options. You either pass the test or fail the test. So whether you took the course, this right here should be pass, this should be fail. Then you have another pass or fail. It does tell you 60% of those who did attend the review course passed the exam. So this is the review, this is the pass, so this should be 0.6 for 60%, which means that this down here is 0.4 for 40% for failed. And it says, while among those who did not attend the course, so this is down here, these are the ones that did not attend, only 20% passed the exam. So for pass right here, put 0.2 for 20%, which means that 80% failed. If this is fail, put 0.8 for 80%. Lastly, what I would do in order to answer these next couple of questions is just multiply. Find the probabilities of everything down over here. So multiply whatever this number is right here times this number right here to find the probability of taking the course and passing the exam. And do the same thing for all four tree branches. Once you have those probabilities, double check that you did it right by adding them all up. They should add up to 100% or 1 if it's in decimal form. And then it makes answering these questions really, really easy.